everybody, Lara here from Theatre of Science. Welcome to another online science lesson. This week, fossils. Big subject, so we're just going to stick to the key points today. We are going to, in order, do how fossils are formed, what is the best model of a fossil, and make our own models. Story time, is Jurassic Park real, woolly mammoths, and poo. How are fossils formed? It's not rock. It's science. Okay, rocks. Rain falls on the rocks, a little bit acidic. Plants try and grow up through the rocks. What else happens? Oh yeah, they get hot and cold and hot and cold, and that makes them get a little bit bigger and smaller and bigger and smaller. All this means teeny tiny little bits of rock come off the big rocks. The rocks travel. These tiny little bits of rock, they're called sediment. They travel downstream, down hills, they get into rivers, they travel through the rivers, they eventually get to the sea. Meanwhile, creatures in the sea, swimming around, they die, sink to the bottom of the sea, and these little sediments come in and cover, if we're lucky, cover these creatures with layers of sediment, and over thousands and thousands and millions of years, all these sediments build up on top of our little sea creature, and all the rock gets compressed because it's got lots of rock above it, and it all gets very hot. If you've looked at my volcanoes lesson and my earthquake lesson, we go into this. What happens after that? Well, a couple of things, but let's have a look at that fossils quiz and see how you did, okay? Because the answers will help us here. First thing you need to know about fossils is usually scientists say that anything 10,000 years old or over is a fossil. So cat prints in cement, not a fossil, they're not old enough. Even a 2,000-year-old bone is not old enough to be a fossil. And Play-Doh, yeah, definitely not old enough to be a fossil. Fossils, we usually think of them as being body parts. Fossils can be body parts like dinosaur bones or shark's teeth, but they can also, a fossil is just any trace that a creature existed. So a poo would be a trace fossil because it's not part of the animal's body, but it's still a sign that something existed, very much a sign. Or a particle of fat even is what we call a chemical fossil. There's some people doing fantastic work with particles of fat, looking into tiny little microbes, and what kinds of fat they had can tell us what the temperature was around them at the time. So a particle of fat would be a chemical fossil, poo would be a trace fossil, T-Rex footprints is also a trace fossil, a woolly mammoth frozen in ice. Yeah, that's definitely a fossil. We're going to talk a little bit about woolly mammoths later, even though it's almost perfectly preserved. Still a fossil because it's over 10,000 years old. True or false? Fossils can tell us about the past, they can prevent global warming. Something can be fossilised while it's still alive. And millions of years ago, whales looked like dogs and walked on land. They are all true, okay? We'll cover all those. This whales thing, I only learned that this week. That really freaked me out. You can't see it from the outside, but actually whale skeletons, they've still got the remains of little hind legs from when they used to walk on land. If you've ever heard the words missing link, that's what we mean by missing link. So we have whales now. We have dog-like creatures that walked on land, but we found fossils of like half whale, half dogs, which is very exciting. So there you go. Sadly, no one has yet made a real dinosaur zoo, and we'll talk about why not a little bit later on. So our poor little sea creature is getting squished. There are other ways of making fossils, like you could get frozen in ice, you could get trapped in amber, but we'll concentrate on this one for today. Two things can happen to our little guy now. The first one, the most common one, is something called permineralisation, which is where water has little minerals in it. It's not just water, it's got loads of tiny little minerals like salt and all kinds of stuff. And if that gets into the fossil, then it can creep into the little creature's pores. Like you've got pores in your skin, everything's got pores, even bone has tiny little holes in. Water with minerals gets into bone, gets into skin, gets into the cells, and then leaves the minerals behind, and they harden up. So you could get a fossil which all the cells are kind of beautifully intact, but it's all the bits of the creature have been replaced with minerals. One of the minerals is silica. Now silica leaves really good fine detail, and silica is found in volcano lava, and plants that live near volcanoes take in silica as they grow, so when they die, they fossilise really quickly. So yeah, plants, they are alive when they begin to fossilise you. How crazy is that? The other way that this little guy could turn into a fossil is if the sand and sediment around it solidifies to make a mould, and then water comes in and leaves layers of mineral behind, and that builds up. So there's two ways. Minerals can get into the pores and stay there, or the sand can make a mould and then the minerals go into the mould. Alright, so let's make our own model of a fossil and decide which is the best model. Some of you have maybe got some chocolate with you, or some bread and butter. Some of you haven't, that's fine. As usual, you can do it with me. So, I was a little bit down on the internet model of fossils. I didn't think it was that great, and I've kind of changed my mind. Usually, the internet will tell you, it's like, get a bit of Play-Doh, stick something in it, and then get something called plaster of Paris and fill in the hole. So that's, it sort of doesn't seem very complicated, but actually that's exactly how footprints are formed. Fossil footprints are just when a dinosaur or any creature steps into some mud, and then sediment, little tiny bits of stone, quickly get into the footprint before it can be washed away, and then it solidifies. So actually, sticking something in Play-Doh, pulling it out again, and then pouring plaster of Paris in so you get like a cast, yeah, that's pretty good. But you can't eat it. So if you've got a yoghurt pot and you want to make a fossil out of chocolate, you need to cut down the yoghurt pot so it's quite small. If you've got a smaller yoghurt pot, then you can still cut it down to be quite small. Just make it like three pastas worth deep, okay? Mine's a bit big, so I'm going to need to use a lot of chocolate. Oops. Here we go. So I've got I'm the teacher, so I've got loads and loads of grated chocolate here. So you put your grated chocolate into your little cup, and then I'm putting my pasta on top of the chocolate. Then some more chocolate on top. I'm using milk chocolate and white chocolate so that we can see the layers, because it is little layers of sediment. So I quite like this model because this does look like layers of sediment, doesn't it? The problem with Play-Doh is that's not really what happens. Layers of sediment build up on top, so there we go. And all I'm going to do now is get my teaspoon and push down as hard as I can. Have a think about why this is a good model and why it's a bad model. Now, when scientists say model, we talked about this a lot in the volcanoes lesson, we don't mean like, does it look good? We mean, is it a good way of explaining what is happening? So, for example, I have got layers of different sediment. So I think that's quite a good way of explaining what happens, because something's fallen in to my mud, and it's getting covered up with layers and layers of other little particles, and then I'm compressing it down, which is exactly what happens. Thank you, Katie. Yeah, I love this t-shirt. It's a DC superheroes. I prefer Marvel, but it's a very cool t-shirt all the same. The other thing I love about this model is that if you do it, you'll notice that all the teeny little bits of chocolate get smushed together. Why? Because of pressure, because I'm putting pressure on. And that's exactly what happens over millions and millions of years under the sea. I didn't say that's why you might have noticed that most of the fossils we have are from sea creatures, because sediment goes like downhill and into the sea. So if you think about like an antelope dying on the African savannah, very quickly it gets eaten, doesn't it, by other things, and then its bones probably get scattered in the wind. That's usually what happened to dinosaurs on land. If we're very lucky, most of the dinosaur fossils that we have are from dinosaurs that happen to be like quite near a river at the time. We don't really know anything about dinosaurs that lived in like jungles, because they never got fossilised. Okay, oh, right, so I've really compacted that down. You might want to stick that in the fridge. Right, let's do the bread and butter one. Guess I'm tired, so I've just made a little sandwich here. Let's just do the same thing again. So this is like the bottom of the ocean. The sea creatures land on it when they're dead, and then layers of sediment build up, and then you're going to push down on top. There. Look at that. So maybe you're thinking, not quite as good a model because it's not layers of sediment, it was solid. But, what you can do with this one is, sometimes the pasta breaks, and that is quite a good model because usually when a fossil is made, the actual creature, especially in the cast version, gets washed away. So if your pasta breaks, that's quite a good model. The other thing that I quite like about this model, it sounds stupid, but I quite like that the fossil is quite hard to get out. You've got to work quite hard to get it out. You've got to be quite gentle. And that's like real life, isn't it? In real life, if you go fossil hunting, you want to find a fossil, you don't just get some perfect cast. You've got to usually like dig and split rocks and stuff. Alright, I'm going to try and split this. I'm not very positive about what it's going to look like, but here we go. Oh yeah, that's quite good actually. I've got butter all over my hands. It's a bit ropey to be honest, but there you go. Which one's the best model? Well, in the cast version, where the rock solidifies and leaves an imprint and then the minerals come in, you need some minerals to come in. So I did end up thinking, how can I improve on this model? Let's open the chocolate one and see what happens, okay? I've done a bit of a Blue Peter. I've done one that I made earlier because I think it's better when it's really cold and it's quite hot around here. Someone used a bread crust and it worked really well. Sad enough, you can eat it whenever you like. Alright, here we go. So this is the one that I just made. It's kind of falling apart. Chocolate people, you might want to leave yours in the fridge for a bit. Oh no, look at that! Ugh. Yeah, I'm having that. That's pretty good. Look at that. So I do like this model a lot because you can see the layers of sediment and it leaves a really good imprint. And I love the fact that the tiny little particles get sort of squished together through heat and pressure. So that's cool. But I have been doing this all week and I was like, I want to do like who has plaster of Paris at home? But what if you could use chocolate instead of plaster of Paris? So I tried imprinting some pasta into some bread and then filled it with melted chocolate. I didn't pop it out because I wanted to do it in front of you. Oh, hey, I didn't think it was going to work, but actually, that is not bad. Hey, look, fossilised pasta. There you go. So if you've got some chocolate and you're happy to melt it, Kat, I'm glad you're just eating yours. That's pretty good. I didn't think that was going to work. So I tried it with some very squishy cake as well. Helen's is absolutely perfect. Good. So these household object experiments really annoy me. It's like, who has plaster of Paris at home? But if you're anything like me, oh guys, look at that! Yes, we just beat the internet, didn't we? Come on, stop ordering plaster of Paris and get some chocolate. Look at that. So that was really squishy cake, like a muffin is good, and chocolate. So, That's not layers of sediment, that's just something squishy. But if you want to recreate like a footprint fossil, that I think is the best model you could possibly get because it's like a creature stepped in some squishy mud, made an imprint, and then some some particles, some sediment, some tiny little bits of rock went in there and then solidified. Yes. This is my favourite fossil that I've ever found on a beach. It's not it's only a shell. Yeah, shells are quite common, but I think maybe it's a cast one because there's just so many perfect details. They're actually quite easy to find. There's a really good website that tells you all the different places in the country and what you should expect to find there. I'll put a link to it on my Facebook page after this lesson. Obviously, you can get big, beautiful ones in shops, thanks to my mum-in-law, and ones that have been like really polished. But it's dead. Honestly, if you go to Redcar, I swear there's more fossils on the beach in Redcar than there are actual stones. These are what I know as deviled toenails, like bivalves, like little sea creatures. But yeah, they're everywhere if you want to go fossil hunting. So, alright, we've nailed the best model of a fossil. We've looked at how fossils come to be. I think it's story time. I'm doing a new thing with story times where we're using Lego again, and I needed a way of moving the phone from one bit to the other. So today, you're not going to see it, but you are going to be riding on this little car, which is just big enough to support my phone. Have you ever heard the rhyme, she sells seashells on the seashore? You could say that with me if you like. She sells seashells on the seashore. The seashells she sells are seashells, I'm sure. They say that that rhyme was written about a woman. She used to be the least known fossil hunter scientist on the planet. She's now kind of famous for being the least known. Anyway, I'll tell you a story. There's a big book you can look in to find out all about very important people who lived in the Victorian times. Mary Anning is not in that book. She does appear in a little pamphlet published a little bit later called People We Accidentally Left Out of the Big Book. But actually, considering how many women are in here, that's still quite impressive. That still tells you what a big deal she was at the time. She was born in a place called Lyme Regis on the south coast, and she had quite a strange childhood. One of the famous stories about her is that when she was a really little baby, she was with 3 people who, when a thunderstorm happened, sheltered under a tree. And unfortunately, the tree got struck by lightning, and Mary Anning was the only survivor. The story goes she survived because someone dipped her in warm water. Do not try that at home. 20 years later, people said that actually she was quite a dull child, and when she got struck by lightning, she became very intelligent. That is not the first time you're going to hear people trying to explain why a poor woman in Victorian England was intelligent. So look out for the other times. Her dad was a cabinet maker and a very well-respected fossil hunter. He used to sell his fossils to people who came to the seaside. People were getting really into fossils at the time. So rich people would seek him out because they knew his were good, and they would take fossils away, maybe for their collection or maybe to study them. Sadly, her dad died when she was very young and left them in an awful lot of debt. The church had to look after the Anning family for a long time. They didn't really have anything. But one thing their dad did leave them was the ability to find fossils. So Mother Mary, she started running a fossil selling business, and daughter Mary Anning was like the lead fossil hunter. When they were only 12 years old or so, Mary's brother found the skull of an ichthyosaur. And a year later, after a lot of hunting, Mary Anning found the rest of the skeleton. I got bored of drawing dinosaur skeletons. You will come to realise that quite quickly. It wasn't the first skeleton of an ichthyosaur ever found, but it was the first to come to the attention of the scientists in London. One of them illustrated it, described it, and started a long tradition of not mentioning the person who found it. In 1995, the skull was still in the Natural History Museum in London, and it still didn't have any information about where it came from on its label. A few years later, a fossil collector called Thomas James Birch visited Lyme, and he found the family living in desperate poverty. They were literally selling their furniture in order to survive because they hadn't found a good fossil for 12 months. And he decided to sell his fossil collection and give them all the money because he wrote to his friend, they have, in truth, found almost all the fine things which have been submitted to scientific investigation. What a thing to say. The gesture created a lot of rumours, but there is absolutely no evidence that those rumours are true. The fossil sale drew a record crowd. People came from all over Europe, and they raised £400, which was a lot of money at the time. Later on, a journalist called George Cumberland in the local newspaper wrote about the very finest specimen of a fossilised ichthyosaur ever found in Europe, which we owe entirely to the persevering industry of a young female fossilist in the name of Anning and her dangerous employment. And he goes on to explain to people how dangerous fossil hunting is. This persevering female has for years gone daily in search of fossil remains of importance at every tide, from many underhanging the cliffs. To her exertions, we owe nearly all the fine specimens of Ichthyosauri in the whole collection. So a lot of people saying that Mary Anning has found basically all the ichthyosaurs that exist. 9 people bought the beautiful ichthyosaur skeleton from the Annings, and they donated it to a museum. The names of the rich people were carefully recorded, and the names of the Annings, sadly not. Anyway, that fossil was destroyed in the Second World War. Boosh. Sorry, there's lots of other ichthyosaurs to see. The same year, Mary found something so weird that people thought it was a fake. It caused a lot of controversy. An important scientist called Buckland wrote that it had the head of a lizard. Can you guess what creature this is? The head of a lizard, the teeth of a crocodile, a neck like the body of a serpent, the ribs of a chameleon, and the paddles of a whale. It was, in fact, a pretty much complete plesiosaurus. And it was bought by a duke, and once again, yep, you've guessed it, all the scientific papers written about it mentioned the duke who just bought it, and not the Annings. But when people were sure that it was absolutely genuine, 23-year-old Mary became famous. People were suddenly coming all the way to Lyme Regis just to see her, and they wrote down what they thought of her, which is where we have some beautiful words that will really tell us about what she was like. So a mineralogist called Thomas said that her knowledge was very surprising and that she had a perfect understanding of the skeletons that she found. A rich woman called Lady Sylvester said, "The extraordinary thing in this young woman is that she's made herself so thoroughly acquainted with the science that the moment she finds any bones, she knows what tribe they belong to. It is certainly a wonderful instance of divine favour that this poor ignorant girl should be so blessed." Isn't that an interesting thing to say, that even though Mary knows a lot, she's still a poor ignorant girl, but God has chosen to make her intelligent? Quite interesting wording. She does go on to say that Mary, because she's read so much and she's done a lot of hard work, she's learned so much that she can easily talk to professors and other clever men, and they all acknowledge that she understands more of the science than anyone else in the kingdom. Because a lot I found about Mary Anning was just sort of the fossils that she found, but if you dig in, turns out she really did know an awful lot about the science. A geologist from New York called her a very clever creature. Yeah, thanks for that. In 1824, she did a lot of work with Thomas Buckland on fossilised poo. She found specimens which showed the connection between the fossilised creatures and fossilised poos that they found, and she hunted for creatures that had fossilised poo inside them. Now, this is the bit of the story that sort of really made me realise just how much she knew. Like, you sort of think, fossil hunting, how hard can it be? If I said to you, oh, hey, here's a piece of poo that's a million years old, could you just go onto a beach and find me a creature that looks like it did that poo? You would probably say no. A few years later, Mary discovered the first British example of a flying reptile, a pterodactyl. Everyone was totally amazed. Buckland wrote a piece about it, and guess what? In the scientific paper he wrote, he mentioned Mary's name and said that she was the person who discovered it. Yay! In case you're still thinking that fossil hunting is easy, a very famous historian living at the time wrote this about Mary: "A genius for discovering where the ichthyosaur lie embedded is but part of the gift possessed by her. Great judgment in extracting the animal, and infinite skill and manipulation must be added." So people are starting to see that Mary's not just good at finding fossils, she's good at knowing about fossils. And people kept coming to visit her shop. A German explorer, I thought you might like this, described her as a strong, energetic spinster of about 28 years of age. And in 1844, the King of Saxony visited, and she gave him her name in a booklet, and she said, as she returned the book, she told him, I'm well known throughout the whole of Europe. So it's good to know that she had a bit of confidence. 3 years after that, Mary sadly died of cancer at the age of 47. Now, history has treated her quite strangely. In 1931, a female journalist called her the first woman geologist, which I think is probably more accurate than fossil hunter, because she only couldn't join the Geological Society because she was a female. But quite a lot of books make her out to be like a little schoolgirl who just found crazy dragons and didn't know what they were, because that sort of sounds like a good story. But we are starting to look back on people and give them the recognition they deserve. The Yorkshire Museum, where I live, they've got a big display about Mary Anning, and if you go on the Natural History Museum website, they've now got a whole big thing about Mary Anning, and if you're lucky enough to go there, you can see her portrait, and you can see lots of amazing things that she found. So if you're ever lucky enough to see an ichthyosaur skeleton in a museum, have a look and see if they mention Mary Anning's name. Right, so the important bit now. We're nearing the end of the lesson, but I said that we would cover could Jurassic Park ever happen, woolly mammoths, and poo. So, first of all, could Jurassic Park ever happen? See, what you need to be able to do is get dinosaur DNA out of a preserved thing. And the problem is, DNA doesn't last that long. And T-Rexes are like 65 million years old. We can, like the oldest DNA that we've ever got, and that was incredible, was about 400,000 years old. So sadly, for that reason and quite a lot of other reasons, Jurassic Park, not very likely. But when I looked into it, it turns out that woolly mammoths were actually around quite recently. Like, woolly mammoths were around about, well, actually some of them only died about 3,000 years ago. But we found DNA inside frozen woolly mammoths, which we can like properly see. Now, it's not like Jurassic Park. You couldn't just get the DNA out of the woolly mammoth and turn it into a woolly mammoth, because it's been bombarded by like radiation from the sun for about 3,000 years. But because we can see what the DNA should look like, DNA, if you don't know, is just the information that tells you exactly what an animal is like. We can go to different animals and find that DNA and put it all together, and we could make a woolly mammoth. In fact, I think they're making a film about people making woolly mammoths, and the film is costing a lot more to make than it would actually cost to make a woolly mammoth. There's 23 genes that are inside an Asian elephant that are also in a woolly mammoth, so they could inject some extra DNA into an Asian elephant embryo, and then an Asian elephant would give birth to a woolly mammal. Why would you want to do this? Because there's some frost in Russia, right? And the frost in Russia is full of quite dangerous gases, which, if the frost melts, would go into the atmosphere and cause a lot of trouble. Like more global warming than if we burned all the forests on the whole planet, like 3 times or something crazy. So we don't want this frost to melt. And it turns out that woolly mammoths walking all over the frost lower the temperature of the frost by about 15 degrees. So they want to bring back woolly mammoths, using fossilised woolly mammoths to help prevent climate change. Another reason that fossils are useful is quite close to my heart, because in the 70s in York they were doing archaeological digs and they found a very famous fossil. They found a 20 centimetre long Viking poo. This isn't it, it's in a museum. This is a prop. But yeah, they found a poo from the Viking times, a Viking person's poo that had turned to stone. Now, this told us an awful lot about, obviously, what the person had eaten. It told us a lot about the climate at the time, like the temperature. But it also told us a much richer story. So Andrew Jones, the professor who found it, he made the international news when he called it the most exciting bit of excrement he'd ever seen, because they found eggs of roundworms in it. And we know now that roundworms live in the digestive tract of humans and have been known to come out of every orifice, every hole of the human body. So Andrew Jones says, you've got to imagine a bunch of Vikings sat around a campfire at night. It's definite that every so often one of these metre-long roundworms is just going to come out of someone's nose or out of someone's ear or out of someone's eye, and they're just going to have to get rid of it. And Andrew Jones said it totally makes sense to him that the Vikings had loads of stories and myths about dragons and serpents and snakes, because how else do you explain worms, dragons, serpents, things coming out of people's noses? So there you go. That's just a way of showing you how useful fossils can be. They can tell us all kinds of things about the world. And that, on that note, is the end of my fossils lesson. I really hope that you enjoyed that. Like I say, if you want to know more about models and general Earth stuff, I've got a lesson on volcanoes and earthquakes, but there's loads of stuff on my YouTube channel. Like we've done amazing animals and the eye and rainbows and planets and all that jazz. If you really enjoyed it, then please like my page and follow me on Facebook and subscribe to me on YouTube and watch all my YouTube videos so that I can finally have enough people watching enough stuff to put adverts on. Thank you to my lovely people who support me on Patreon. I've written your magazine and it's off with the glorious Institute of Physics who are checking it to make sure that all the stuff that I wrote about Einstein's theories is right before I send it to you. And that's all there is left to say. Thanks very much for joining me. Bye! Thanks Charlie, age 9, hello. Finn from Manchester. Leicester has the oldest fossil found. Some sort of plant that lived under the sea. Okay. Oh, Evan and Finley. Yeah, I know, real woolly mammoths. How crazy would that be? Just imagine that. Bye-bye, everybody. Bye-bye. Structural stability. Ooh. Not sure that would get me as many likes as fossils, Anya, but I'll think about it. How did the dinosaurs get wiped out? Oh, Alison, that's a good question. It was probably a combination of a big meteorite hitting the Earth and a volcano at the same time. Zach and Henry, hello. A lesson on light bulbs. Do you know what, Zach and Henry? Because you said that, we'll do electricity next week. Harrison, you wearing your Marvel t-shirt? Oh, that's good. That makes up for me being DC. Do you know what fossil poos are called? Oh, did I not say that? Oh, yeah. Sorry, thanks, Emma. Should have told everyone that a fossilised poo is called a coprolite. Yeah, Sarah, it's quite a cheap trick, isn't it, mentioning poo early on? I think I'll try and work it into electricity somewhere. How do you find out what your fossil is of? Harrison, that is a very good point. There's a lot of very generous people who know a lot about fossils on chat rooms, or like, not chat rooms, but forums, which is where you can post pictures, and if you're very nice and polite, they might tell you. Oh yeah, even Chloe, thank you for reminding me. I'm doing breakfast science tomorrow. Oh, thanks even Chloe, that's what I meant to say. So while I researched this lesson, I accidentally found out quite a lot of stuff about the evolution of life on Earth. So tomorrow at 8:30, because that's the only time my childcare works, we're going to have a look at the history of life on Earth. We're going to look at that, you know, that drawing that you see in museums, like all the different coloured layers, like Devonian period, Cambrian period. We're going to look at that, because I didn't know anything about it, and I do now. Finn, how do they extract the DNA from fossils? Good point, Finn. Wish I hadn't read that out now, because I don't know. Yeah, sorry. How many fossils have been found? Nicholas? Well, a lot, but a real lot. But it's a tiny amount of things that get fossilised compared to stuff that just disappears. Jessica wants a whole lesson on poo. Oh, did I know that dinosaur means terrible reptile? Holly and Finn, thank you for that. Yeah, let's all go back to our lives. I'll see you tomorrow. Bye, Marta. Bye.